fitting can match the purchase order and still fail the engineering review. The material grade may be unverified, the pipe and fitting dimensions may not align, the barcode may be unreadable by the selected fusion unit, or the installation record may not connect the completed joint to the delivered batch. Any one of these gaps can appear minor. Combined, they create a significant operational risk. Electrofusion is valuable for constrained spaces, branch connections, repairs, and locations where but fusion equipment is impractical. But approval must connect 4 elements: the exact fitting, the nominated pipe, the fusion machine, and the site procedure. That connection can be established through 6 evidence gates. Gate 1 confirms identity and dimensional fit. The submittal should state the part number, fitting type, nominal size, SDR where relevant, material designation, and intended pipe interface. Generic descriptions are not enough. Couplers, elbows, reducers, T's, tapping T's, and saddle branches each introduce different dimensional checks. Reducers require both ends to be documented, while branch fittings require verification of both parent pipe and branch pipe data. A line-by-line dimensional schedule should map every fitting to the nominated pipe series before the order is released. Gate 2 matches the fitting to the service conditions and applicable standard scope. Water and gas claims must remain separate because they represent different service contexts. References to ISO 4427 or ISO 4437 begin the review. They do not complete it. The reviewer must check the document edition, product category, material, size range, pressure class, test basis, issuing body, date, jurisdiction, and relevance to the proposed configuration. Mining and industrial duties may also introduce abrasion, chemical, temperature, access, or operational constraints requiring separate acceptance criteria. Gate 3 establishes traceability. Statements about automated production or resistance inspection become meaningful only when they can be linked to the delivered product. The evidence path should connect each fitting identifier to its lot or batch and to the relevant production or inspection record. If resistance inspection is based on sampling, the sampling method and acceptance threshold should be documented rather than assumed. Gate 4 verifies barcode and machine controls. A barcode can reduce manual parameter entry, but it cannot replace a controlled procedure. The selected fusion unit must read the required code format. The terminals must suit the equipment, and the machine must be maintained or calibrated under the project plan. Where pipe source, equipment, site conditions, or fitting geometry create uncertainty, a trial fusion on representative pipe can expose interface problems before production begins. Gate 5 addresses installation discipline. The approved procedure should define pipe preparation, scraping or surface treatment where required, alignment, clamping, cooling protection, contamination control, weather limits, and the handling of damaged components. Operator competence must also be verified. A well-documented fitting can still be compromised by poor preparation, movement during cooling, or uncontrolled field conditions. Gate 6 closes the approval loop through retained acceptance records. The completed joint should be traceable from its field location to the fitting identity and fusion cycle. The record should include the location, date, installer, machine identifier, fitting barcode or code, pipe details, observed cycle result, and applicable inspection or commissioning reference. Evidence should be evaluated by priority. Product identity and service suitability are critical. Unresolved gaps should stop approval. Traceability, barcode compatibility, and installation controls are high-priority requirements that need documented project actions. Fusion logs, inspection hold points, and closeout records support final acceptance but cannot compensate for missing critical evidence. Supplier listings can accelerate initial screening by presenting material, SDR, terminal, resistance inspection, or barcode information. Those claims are starting points, not automatic project approvals. The decisive questions remain: which exact part is proposed? Which duty must it perform? What evidence covers that part and duty? And what field record will prove that the joint was installed by the approved method? A sequential, evidence-led review makes risk visible while it can still be controlled, before fittings reach the work front and before an undocumented joint disappears beneath the ground.